Hello and welcome. My name is William Bowling, also known as Vax, and in this lightning talk I'll be walking through my process for how I discovered an arbitrary file read in GitLab and how it was possible to turn that bug into remote code execution. So a little bit about me. I've been working as a software developer for about 10 years now. I'm currently working for a startup called Biteable out of Tasmania, Australia. The majority of the stuff I do at work revolves around a Rails backend with a TypeScript and Ember front end. I've always been really interested in computer security, and in my free time I love participating in CTFs with my team Open to All. And more recently, over the last year, I've started doing quite a few bug bounties as well. I guess my bug bounty journey really began about June last year when I read an excellent report on HackerOne about overwriting files in GitLab by injecting Git command line options. Um, I found it really fascinating. It was sort of a whole glass of vulnerabilities that I'd never really thought of before. So even if you sanitize all the input correctly and use the correct methods for running a command, it's still possible if the argument starts with a dash, it could be interpreted as an option to the command instead of as, a path or a file name. So after reading the report, I started looking into GitLab to see if there were any more places where a similar technique could be used. And after a bit of testing, I discovered that there were quite a few similar issues throughout Gitly, which is the service that GitLab used to wrap all their calls to Git. And quite a few of these could be abused. The worst one was allowing semi-controlled content to be written to an arbitrary location. And you could use the same technique as the original report to overwrite the authorized keys and gain remote code execution. GitLab's a very open company and they have a pretty good track record with security. So I thought if they had some issues like this, then quite probably other services might have similar types of issue, which did turn out to be the case. I managed to find a similar issue in GitHub, which allowed files to be truncated or blank files created. And there was a file write to RC bug in Bitbucket, and both of these were abusing the same Git argument injection technique. After finding and reporting these issues, I was having quite a lot of fun with bug bounties, and knew it was something that I wanted to continue with and to learn more. Fast forward to March of this year, and I was reading through the patch notes of the latest GitLab security release, and the first issue there was titled Directory Traversal to Arbitrary File Read, which sounded like a pretty big deal. GitLab normally discloses the original ticket about 30 days after the fix has been released, but because it's open source, it's normally pretty easy to find the commit by comparing the previous release, and from there you can work out what the issue was. So looking at the commit, the patch to fix this issue was pretty small. It just added some validation to a secret field on a file upload. Also with the patch, there was some pretty good test cases that were added and a few fixed, which gave a pretty good outline of how the issue could be reproduced. After the patch, the route and secret parts of the file uploader class looked a bit like this. Previously there was no restriction on what the secret could be, and the secret's used in the dynamic segment, which is used to determine the location of the file. So if instead of the secret, path traversal was supplied, it could have allowed for an arbitrary file to be read instead of the intended one. This was a much more standard type of bug, but it got me thinking again, and I wanted to dig a little bit deeper and see if there was any similar issues that could be found. I'm pretty familiar with Rails and normally use RubyMine as my IDE for it, as it makes it quite easy to trace core hierarchies and find out where and how different things are used. Um, Also, when you're running GitLab locally, you have access to the Rails console, which allows you to interact directly with any of the models and quickly test and discover different things. GitLab uses a gem called Carrywave to handle a lot of the heavy lifting for file uploads. So I started looking into that and just reading up on how it works and how it was used by GitLab. I started looking at the note model, which is the base for things like issues and snippets in GitLab, and it can have attachments added to it. And while trying a few things out in the Rails console, I noticed a method called remote attachment URL, and didn't seem to be defined anywhere in GitLab. It turns out that when you use the carrywave method mount uploader, it creates a bunch of other helper methods as well. This one allowed a URL to be given, and it would go download the URL and attach it to the model as a file. This wouldn't normally be an issue, but due to how GitLab project imports work, it's actually possible to modify the JSON of an export to get this property to be set, which downloads the URL and adds it to the note as an attachment. Since this fetch was done in the carrier-wave gem, it bypassed all of the server-side request forgery protection that GitLab have in place, and allowed internal services to be queried and have the output attached to the note. I then came across a class called Uploads Rewriter, which had a pretty handy comment at the top explaining that it was used to copy files to a new project and then rewrite all of the links to the new file. So this would be used when you move an issue from one project to another, to also copy the files with that issue and change any of the links to point to the new location. I started tracing through the class, and first of all it checks whether anything actually needs to be rewritten. Does this by scanning through the issue text for the specific markdown pattern, and if one's found, it calls find file, adds it to a list, which is then filtered to remove any files that don't exist. The find file method takes a project, secret, and a file name and uses them to create a new file uploader, and then calls retrieve from store method to fetch the file and populate the uploader, which allows for other operations like read and copy and move to be performed on it. So if there are any files that need to be written, it does a similar thing but using gsub this time to match and replace the markdown pattern. The find file and exist checks are done again, and if this passes, the file's copied to the new parent, and it replaces the link with the new one. I was trying the steps of the find file method in the Rails console, and found out that if the retrieve from store method is passed a path with a directory traversal in it, then it still resolves and attaches the arbitrary file. Going back and looking at the markdown pattern, you can see that secret has to be valid, but there's no restriction on what the file name can be. It'll just be whatever's left over before the final bracket. This led to the following markdown snippet. If you create an issue with this markdown link and then move the issue to another project, it would go and copy etc password and attach it to the new project. This was already a pretty critical issue. First confirmed that it affected GitLab.com and then quickly reported it. After that, I started looking to see if it was possible to leverage this arbitrary read any further. I'd previously run Brakeman over the codebase, which is a static security scanner, and one of the things it reported was that GitLab were using the hybrid cookie strategy, and mentioned that that could lead to remote code execution. The Rails used to use Marshall to serialize Ruby objects for signed and encrypted cookies, but since has moved to a JSON strategy instead. The hybrid strategy was added as a sort of migration path so that it would take the old marshaled cookies, read them, and then convert them to JSON. Quick search found that GitLab were using a signed cookie to store the experimentation ID of a user. It was checked on most endpoints. Deserialization of untrusted data into Ruby objects is pretty dangerous, especially with a large code base like Rails where there's lots of gadgets available. And there's quite a few guides on how to achieve code execution using something like this. To prevent untrusted data, Rails signs the cookies with a value from a secret key base, so that way it can tell if the data has been tampered with and throw it away if it has. So combining all of this, we can use the arbitrary file read to leak the secret key base. We can then use it to sign a malicious Ruby object and then send it to Rails via the experimentation subject ID cookie, which will then be deserialized via Marshall due to the hybrid cookie strategy, causing our payload to be executed. So that's been my bug bounty journey and a bit of a look at what my process is like. I'll just leave you with a few things that have really helped me along the way. And try to read as many disclosure reports and write-ups as you can, even if it's something that you know already or pretty familiar with. There's often like a small little technique or trick that could be helpful in the future. If you work on a program that has patch notes, make sure to go through them and see what the most recent issues have been. You can either look at the commit logs if they have them or do some patch analysis to discover what the original issue was. And finally, I think it's pretty hard to fix an entire class of vulnerabilities with a single patch. So if there was a particular type of bug that was fixed, it's quite possibly that there are a few more hiding away.